The new delivery drone hovered above the school courtyard, its rotors humming like a swarm of bees. The learners watched as it rose, paused, then tilted forward and sped toward the hills. "It doesn't just guess where to fly," said their teacher. "Its path is calculated." Naledi, who loved both maths and technology, was part of the coding team testing the drone. Today's mission was tricky. Deliver a medical package to a mountain clinic without hitting trees, towers, or steep rock faces. "We know the clinic is 800 meters away horizontally," Naledi explained, "and it sits higher than us." The drone measures its angle of elevation to the landing pad. Her tablet updated. Angle equals 32 using a right triangle model. She calculated the height difference using trigonometry. "We use tangent," she said. "Angle, opposite side. Adjacent side, that tells us how much higher the clinic is than our launch point." Within seconds, the system adjusted. Required climb height, computed. Safe flight angle set. Descent slope planned. The drone smoothly changed its pitch and followed the exact path. Minutes later, a message came through. "Delivery successful." The class cheered. Naledi grinned. People think drones are all about motors and batteries, but they're also about triangles and angles. Her teacher nodded. That's trig in real life. Not just solving for X, but solving for altitude, distance, and safe routes through the air.